I've gotten some questions about the chi-square test on MSL 10. Uh, the first set of questions I've gotten have had to do with just how long it takes to calculate these things and how tedious they get. I'm going to address that. The other question I got was about calculating the p-value. So you go through all this, you calculate your chi-square statistic, and then sometimes the p-values can be a bit confusing. And I'm going to show you how to handle both of these by running through an example of MSL 10 problem number 6, which asks you to do a chi-square test of independence of two categorical variables. So I'm just going to start this with a fresh one. First of all, when I click here, and I'll click on here to open up the data in Excel, so that's going to download the spreadsheet. So the first thing to notice is that this has two variables, but there are a lot more levels here than in the example that I did on the video. So typically what we've done, I'll show you the slide, is we've got two variables here, and there's two levels of each categorical variable. So for gender, there's only male and female, and for hand preference, there's only left and right. So after we do this thing where we calculate the observed and the expected, we wind up with 4 different cells, and that means when we're calculating the test statistic, we've got 1, 2, 3, 4 different terms that we're adding up. So this is the squared difference over, this observed minus expected squared over expected, and then you do this for each of these 4 cells. Now, if we look at this, we have got 1, 2, 3, 4, 5, 6, 7, 8, 7 different levels for music, and 1, 2, 3, 4 different levels for age group. So we're going to have 1, 2, 3, 4, so 7. So we're going to have 28 of these squared terms. So as you can see, that's going to take a long time. That's going to be very tedious to calculate. And so people have asked me, well, is there something I can do that, to kind of work around this? There is, but not with the data analysis tool pack that we have, but I will direct you to a tool that does provide a chi-square test shortcut. Let's see, it's if you go to realstatistics.com, here it is. So this URL is just real-statistics.com. This is sort of like the data analysis tool pack, where it inserts a set of tools into Excel, and it's a free download. You can download it, and then once you install it, the installation process is very close to what you do with the data analysis tool pack, so similar instructions. And once you go through that installation process, once you have installed it correctly, I actually had to just go and reinstall it, because sometimes it uninstalls itself. You'll have this add-ins tab that will have this Real Statistics tab on it. So I'm going to go ahead and click on that, and it launches a dialog window that's really similar to the data analysis tool pack, but it has a lot more in it. And you'll see that there's descriptive statistics. This is regressions and ANOVA. We're going to do some more of these when we get into logistic regression. We're going to be down here. But for now, to do the chi-square statistic, if you come all the way over here to miscellaneous, it's got a chi-square test for independence here. So this will do all those calculations for you, and it'll even show you the output so that you know how it got what it got. So I'm just going to select that, click OK. The input range, you click on this little underscore here. I'll select the whole table. It includes the labels. I'm going to go back and double check what the problem wanted in terms of significance level. Okay, so 0.05. So I'll go back here. 0.05 is the default, and I'll go ahead and put the output right there. Okay, so I'll click OK and close this. And so this generated that table of expected values. So these are the values that we would expect to see in those cells if these two categorical variables were in fact independent. So the chi-square test kind of summarizes how far these expected values are from the observed. And so the chi-square statistic, which is over here under Pearson's, so right there, so that's the actual chi-square statistic, which is going to be that minus that squared over that plus, all the, what did I say, 28 times. So this is, quite a bit of a shortcut here. And I'm going to go ahead and answer the problem just to make sure that this matches what they got, the values that they're expecting for the homework. Okay, so first of all, for chi-square statistic, the null is that there is no relationship between these two variables, which makes the alternative that there is a relationship. Okay, so now we want to put that value for that Pearson's chi-square statistic there and see if it matches. Let's see, number of decimal places is 2, so 142.82. Hopefully that's right, 142.82. Okay. Okay, so now, determine the p-value and round to 3 decimal places. So suddenly we're rounding to 3 decimal places. We'll take note of that. So if we look back here, this does give us the p-value, but notice that it's in scientific notation. And what this means is, it's 1.828 times 10 to the minus 21. So, you take that decimal point and move it 21 places to the left. So I'm going to, just so that you can see what happens, if you really want to actually visualize how small this number is, you can select on the cell and then, just reformat this as a number, and then just keep widening it until you actually do see something that's not a 0. Okay, so that's how small that number is. So this is telling us that if these two variables were actually completely independent, this is the probability of seeing a chi-square statistic this large. Okay, and we see that it's a very, very low probability. And if this asks us to round to 3 decimal places, well then, if we're only considering 3 decimal places, then it is essentially 0, because we have to go 21 before we see anything that's not 0. So, and that is the correct answer. Now, so what if I just gave you the chi-square statistic and said, okay, I want you to calculate the p-value. Let me show you. So this is the statistic right here, and I'll just say, okay, this will be the manual chi-square, or manual p-value. Okay, so how do we calculate the p-value of that? So remember that the chi-square distribution is shaped very much like the F distribution for the ANOVA, which means that there's no negatives, it only goes positive. And we're mostly only concerned with the amount of area on the right of that curve. So we are always, in the case of a chi-square distribution, when we're trying to find a p-value, we want the amount of area to the right of that curve. So we're going to start with 1 minus, okay? And so now we just do 1 minus chi-square dist, chi-s cubed, you can't see it there, the helpful tool pop-up got in the way, chi-square dist, okay? So now it's prompting me for the x value, okay? So that's just going to be that chi-square statistic there. Now the degrees of freedom, well, so for this particular test, it's the number of rows minus 1 times the number of columns minus 1. So I said we had 7 rows, so that's 6. And we had 4 columns, so that's 3. So 6 times 3 is 18. 18 degrees of freedom, and cumulative is true. Okay, so it says that that's 0, but that's not really 0 as we saw. It's something very close to 0. Let's see if I expand this, if it'll... Okay, so it never quite gets I mean, it should be close to this, but there's always rounding issues going on with with programs, so it's basically 0. Okay, so but this is the way that you would go about calculating the p-value of this particular chi-square statistic. Okay, you see that we've also got another statistic that we could look at, the maximum likelihood. We're not going to cover that, but this should And then, of course, the rest of this problem is just about what's the conclusion. Obviously, with a p-value that small, we are going to be rejecting, and so there's insufficient evidence of no, there is sufficient evidence of a relationship. Okay, so so that's how you do the chi-square test without having to calculate all those individuals. Again, this tool pack that we got here is at realstatistics.com. It's got a lot in there, a lot more than the analysis tool pack has, but it can be kind of complicated to use. Okay, well, good luck with that, and let me know if you have any more questions.